Hello, this is Dr. Sharice Flanagan at Abilene Christian University. The following video contains Part 1 of Introduction to Statistics, which will be utilized in tests and measurements. It contains key concepts and terminology that you will need to be familiar with this semester. For some of you, this may come as a review if you've had some exposure to statistics, but for others of you, it will be brand new. I hope you find it to be helpful.
Math is a wonderful thing. Math is a really cool thing. So get off your ass, let's do some math. Math, 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 math. 3 minus 4 is...
-1.
That's right. And 6 times a billion is...
6 billion?
Nailed it. And 54 is a 45 more than what is the answer, Marta?
9.
No, it's 8.
No, it's 9.
Yes, I was testing you. It's 9. And that's a magic number.
Now, all silliness aside, we will get started on Part 1 of Introduction to Statistics. There are basically 3 things that we're going to cover in Chapter 1. For Part 1, we're going to talk about variables and systems of measurement. For some of you, this will be review. You've seen this in other classes that have included some statistics, and for some of you, it'll be brand new. But they're important definitions that you want to take note of. There will be a Part 2 that covers that measures of central tendency that you see right there. A variable is anything that can take on more than one value. This is a term you've heard your whole life. You use that term indiscriminately to talk about different things. But in this case, we want to be very specific about our definition. A variable is something that can be measured, controlled, or manipulated. In research, we can change the values of that. There are constants in research, and those are variables that remain the same. They're present in every research design. However, they play a different role in the type of measure that can be applied to them. We'll talk a little more later about independent variables, but these are a specific kind of variable which we manipulate. An independent variable is one that we manipulate, and we also call them predictor variables. Usually an independent variable consists of 2 or more treatment conditions in which subjects are exposed before the dependent variable or the criterion variable is observed. So these are terms that we're going to use and study, independent and dependent variable. The dependent variable is measured or registered as the outcome variable, and it's dependent upon what happens with the independent variable. These are some examples of different types of variables that can take on different values. So age, that's a number, and you can see that that can easily be a specific number, your specific age. Gender is also a variable. We don't typically look at that as a number, but in research we have to assign it a number typically to manipulate that data. Ethnicity is the same way. Score on a test, that's a number, also a variable. And then the students who read material or listen to this lecture before coming to class, that could be a variable. Okay, we're going to talk in broad strokes about measurement, and we're going to look at the way we assign labels to variables according to a set of rules. For example, if you've ever been on an athletic team, you've had a jersey number assigned to you. Okay, but here's the big picture. 4 types of measurement: nominal, ordinal, interval, ratio, NOIR. You need to memorize right away the order that these come in. I'm going to talk about each one of them, but it's important that you learn these and learn them in order because they do become progressively more sophisticated as a type of measurement. So I want you to look at that blue line up there that says 4 types of measurement, because I want you to understand that this is the umbrella term for these things, these nominal, ordinal, interval, ratio. You will encounter these types of measurement in every statistics class you take, in every statistical software program, and so this is very important basic stuff that you need to learn and commit to memory. The first type of measurement is nominal. Nominal measurement are variables that have labels. They, in this case, we have to assign numbers to quantify or classify. It's the least sophisticated type of data. It's always qualitative, meaning that they don't naturally have a number that come with them, like gender I was just talking about. The way that I remember this is to remember that when you look at variables and you're trying to decide what type of measurement it is, nominal variables are often demographics, and they are always mutually exclusive, meaning that you cannot be one or the other, gender, male or female. Now, as social scientists, we know that sometimes people will assign themselves something in another category of gender, but for the purposes of argument, let's just say gender, male or female. Eye color. You either have brown eyes, green eyes, blue eyes, or hazel eyes. You are in one or the other. Handedness, you're right-handed or left-handed. So this is nominal, and if you've had Latin, you remember the name nomen, which is Latin for name. So nominal is another word for naming variables. Now, this is just a slide that shows you the kinds of statistics that we use with nominal data. We've got the chi-square, we could do frequencies and mode. I understand that this means nothing to you yet, but this is just kind of a point to make that there's not a lot we can do with nominal data at this point. And what it is actually pretty simple. All right, the second type of measurement is ordinal. So we've got nominal and then ordinal. Ordinal variables imply intensity or severity, and they are in a sequence from lesser to greater. So you want to think about them as being ordered along some sort of continuum. And they have rank. So some are more than others. Think about college football top 20. The number one ranked person has better statistics than number 20. Letter grades. An A is better than a B, which is better than a C, and so on. Likert items. We will talk about Likert items exhaustively. If you don't know what that term means, Likert item is something that you've encountered many, many times in your life, and that is the strongly agree, neutral, that kind of thing. It's the sort of thing you see on surveys all the time. And then IQ scores are ordinal data. Okay, with ordinal data, we still can't do a lot with ordinal data. We can run frequencies, we can use mode and median. The third type of measurement is interval. This is the type of measurement that assigns numbers to observations that reflect a constant length between units of measurement. And we assign a value to a specific value, and it is on a continuum. It has equal intervals. All right, so the best and most used example of this is temperature scales, Celsius, Fahrenheit scales. The point here is that interval data is very similar to ordinal. In fact, it's exactly the same, except that difference between point A and point B and point B and point C is exactly the same. It has to be exactly the same, like you would see in temperature scales. Okay, statistics with interval data. Look at this. We could do a lot more with this. We can still do the frequencies, but now we can look at means. And that's your arithmetic average. We could do t-tests and ANOVAs and correlations and regressions. Again, I know that this doesn't mean a lot to you yet, but I just want you to make the note that as these types of data become more sophisticated, so do the analyses. The last type of measurement is ratio. And this is when we assign numbers to observations to reflect quantity with reference to an absolute zero. If you're taking notes here, you need to circle or underline or write in big bubble letters absolute zero, because that's what's important about the definition of ratio. You rarely see this because it's hard to have an absence of something. But that's when we can still put things on a continuum, like we've done with interval and ordinal, but in this case, there is an absolute zero. Think about height. There, you start at 0 and you go up from there. Weight, 0. Speed of travel is my favorite example because you can imagine that you're looking at that speedometer and you have it set on 0 and then you start driving. So that is ratio measurement, is when you have an absolute 0. And boom, look at this. The statistics you can use with ratio data, everything that you can do with interval, and then, yeah, I think I've got Pearson correlation broken up into 2, but those are actually the same thing. Those are types of correlation. Okay. Now I want you to quickly classify the following. I'm going to pause here and let you think about what type of measurement you would put these following things into. Okay, and here are the answers. Hopefully you were able to determine that time was interval data. That's the second type, where you have the same, you have rank. Remember, nominal, ordinal, interval. Interval data has the exact same space between, in this case, say 2 o'clock and 3 o'clock, and 3 o'clock and 4 o'clock. It's exactly the same. USDA stickers placed on cuts of meat. Now, you would have to know, and some of you may not if you haven't cooked much, that those labels, prime, lean, etc., do imply rank. So one is better than the other. And that's why it is ordinal data instead of nominal data. If you thought it was nominal, it's because the lean cut is better than prime, etc. Now, political party membership is nominal. You may find some argument with my father-in-law here. He would consider that to be ordinal, with one definitely better than the other, but that's not the case. When you're classifying data, they're mutually exclusive. You're a Republican, you're a Democrat, you're an independent, etc. So it is nominal. And then the last one, percentage scores on an exam. That is ratio, because you can have an absolute 0, which I certainly hope that you do not. Okay, just a few more points here. Qualitative data is data that represents an attribute that can be assigned to a category. This is what we've been talking about with nominal data. Okay, it's qualitative, it's unordered, and you have to assign it to a category, basically. Quantitative data are variables whose values are determined by counting or numerical measurements, and those numbers already have meaning before you assign them meaning. So number of children in a family, body weight, etc. Here's some examples of quantitative data: IQ scores, number of TVs in your home, number of trials it takes to learn a list of words, your reaction time, age at which a child says their first word, and height. Here are qualitative data. Keep in mind that this is nominal data, okay? Typically speaking, gender, marital status, religion, those don't already have numbers that come with them. So we have to assign them numbers, and we will do that, and I'll show you how to do that when we get into SPSS. Now for a summary, I'm going to ask you some questions, and if you want to give yourself time to think about those, you need to pause after I ask the question. What are the 4 types of measurements? And there's your answer. How is qualitative data different from quantitative data? What color is noir And why do you care? And finally, what is the magic number?
What is the answer, Marta?
9.
No, it's 8.
No, it's 9.
Yes, I was testing you. It's 9. And that's a magic number.